Hello guys, welcome to Code with BK. So in this video we solve the problem to clear the ith bit in an integer n. So in the first half I'm going to explain you the process to solve this problem, and in the next half we look at the codes. So if you're someone who's just looking for codes, the link to the codes provided in the description of this video, and to each link there is a text explanation as well. So if you're someone who wants to read and understand, you can take a look at that as well.
Please do not forget to subscribe to this channel and click on the bell icon to receive all the latest updates.
So what do I mean by clearing ith bit in an int n? So let's take n equal to 27, okay? Taking an integer n equal to 27, the corresponding binary value for this 27 is 11011. So integers in computer science are stored as 32-bit values. So these are 5 bits and these 5 bits are padded with zeros on the left. So these are 27 zeros, okay? These are the remaining 5 bits, making a total of 32 bits. This is bit number 0, 1, 2, 3, 4, so on till 31st. So the rightmost bit is bit number 0. So suppose I equal to 1, okay? And I want to clear the ith bit, that is, I want to set the value at I equal to 1 to 0. That is, set the bit at bit position 1 to 0. So when I want to clear the first bit, this becomes 11001, setting bit number 1 to 0 and leaving all the remaining bits the same as they were. So bit number 2, 3, 4, 5 till 31. So how do we achieve this? So let me write n equal to 27 here. Okay. So this is basically 27 zeros, then 11011. We have to get this from this. So for clearing I equal to 1, that is clearing the first bit, I take a value which has 0 at bit number 1 and 1s at all the other places. Okay. So 1s at all the other places, okay, and 0 at this bit number, okay, which is bit number 1, okay. And then I perform the bitwise AND of these two values. So each bit, okay, we do bitwise AND. So we know the rules for A dot B. So A dot B is 1 if both A and B are 1, otherwise if one of the values is 0, A dot B is 0, okay. So 1.1 is going to give us 1, 1.0 gives us 0, 0.1 gives us 0, 1.1 gives us 1, 1.1 gives us 1, and all these values are 0. So each 0 when multiplied with 1 gives you 0, okay. So basically you get this value that we were looking for, setting bit number 1 from 1 to 0, that is clearing bit number 1 and leaving all the bits the same the way they were. So if we can find this value, we can do bitwise AND of n with this value to get the answer we are looking for. So how do we get this value? We need to have a 0 at bit number I and all the other values to 1. So I start with x equal to 1, which is basically all zeros except the last one, which is 1. So these are 31 zeros, okay, and the last bit is 1, making a total of 32 bits. Then for I equal to 1, I left shift x by I places. I do x equals to x left shift I places, okay. That is, all the bits are shifted left by I places. In this case I is 1, so left shifted 1 place, okay. So 1 is at bit number 0. So when you do this, when you perform left shift, okay, so 1 comes at bit number 1, okay. So these are 30 zeros, okay. These are the last two bits, bit number 0 and bit number 1, okay, 2, 3 till 30, 31. So when you do this, you get a value where bit number I is 1 and all the other values are 0. We need bit number I to be 0 and all the other values to 1. So we perform a bitwise NOT. So basically when you do NOT x, all the zeros change to 1 and all the ones change to 0. So this becomes, okay, so these are 31s and the last two bit number 0, bit number 1, bit number 2, bit number 30, bit number 31. So when we do these 3 steps, we get the value we need, setting bit number I to 0 and all the other bits to 1, okay. So if this is x, okay, and we perform ampersand, this y is basically n ampersand x. So writing the pseudocode for this, we write a function clear ith bit. This function returns a value which has the ith bit cleared in n. So what do we need now is the value x. We start with x equal to 1. We left shift x to I places. X is x left shift I places. This operator is provided in programming languages. Okay. Then we do not of x. X is bitwise not of x. This is also provided in programming languages. And then finally we do ampersand of n and x. We return n ampersand x. You could take a y equal to n ampersand x and then return y. I am directly returning the value. Okay. So this is how you clear the ith bit in n. Let's take another value of I, say I equal to 3. Okay. So x starts at 1. Okay. So 1 is basically all zeros except the last one. So 31 zeros and the last one is 1. So 1 is at bit number 0. Left shift by 3 places comes at bit number 3. Okay. So 1, 0, 0, 0. Bit number 0, 1, 2 and 3. Was at bit number 0 comes at bit number 3. Then you do bitwise not. All zeros change to 1 and all ones change to 0. Then we perform bitwise AND with n. Okay. So this is n is 1, 1, 0, 1, 1. Okay. And this is all zeros. Okay. So 1.1 is 1, bitwise AND. 1.1 is 1, 1.0 is 0. 0.1 is 0. 1.1 is 1, 1.0 is 0 and so on for all the other zeros. Okay. So for this value n, you change the bit number 3 from 1 to 0. Okay. And all the other bits remain the same. So this is how you clear the ith bit, and let's move on to codes to check the implementation now.
So this is the implementation of the solution we just discussed. So I've written a helper function clear ith bit that takes an integer I, an integer n, and it clears the ith bit in n and returns the updated value. Okay. So in my main, I have n equal to 27 and I want to clear the bit number I, which is 1. Printing n and then printing the value that you get after clearing the ith bit in n. Okay. So let me run this Java C and Java. Okay. So when you clear bit number 1 in 27, you get 25. How do we check this? I take this code that converts decimal to binary. So I've already posted a video that discusses how to write this method. Okay, I'll link that video as well. So I will print n in binary first. N in binary is decimal to binary n. Okay. And then I take m, which is formed by clearing the ith bit in n and printing m in binary. Okay. So we can see that the bit is cleared. Compiling, running. Okay. So 27 in binary is 11011. When you clear bit number 1, which is this, you get this. Okay, which is 25. So you can clear bit number 3 as well. Okay. So compile, run. This is bit number 3. Okay, which you then when clear you get 90. Okay. So I hope this video was helpful. So please do like this video and subscribe to my channel for more such videos. And please let me know in the comments if there was anything not clear to you in this video, if there is a concept you want me to discuss, or if there is a question you want me to solve. Thank you.